In this lesson, we discuss options, reflection, interpolation, and refraction interpolation rollouts of the V-Ray material. We are using the same scene from the first lesson of this section. I've just applied a highly reflective material to the shader ball. So let's close the basic parameters and BRDF rollout and open up the options rollout. Let me just run the active shade, as we will need this for some of the options here. First, we have trace reflections. If disabled, you basically disable reflections and only can see the highlights. Trace refraction gives you the ability to completely turn off refractions. Next, we have cutoff, which is a threshold below which no reflection or refraction will be computed. So if the contribution of these materials, reflection or refraction, is below this number, they won't be computed. If I set this number to a very high number like 0.9, for example, you can see the reflections are basically gone. Then we have environment priority. If you come down here to the maps rollout, you see you can define an environment map. And if you define this map for this material, this map will be reflected by this material instead of the environment map defined for the scene in the environment and effects window. Environment priority determines the environment to use if a reflected or refracted ray goes through several materials, each of which has an environment override. Next, we have effect ID. To access this option, first you need to enable override material effect ID, and now effect ID can be used to input values for material ID. I will be discussing this more when we get to the render elements section of this course. Next, we have double-sided. When enabled, V-Ray will flip the normal for the back-facing surfaces with this material. Let me just quickly show you how it works. First, let's adjust the material a bit. Use a purplish diffuse color maybe and change the IR to something like 2 maybe. Now hide the shader ball and create a sphere. Delete some of its polygons here. And now let's apply the material to the sphere. Now if I run the active shade with double-sided enabled, we can see we have the exact same material applied to the backside of our surface. And if I disable double-sided, you can see the backside polygons are more like a translucent surface that allows the light rays to pass through them. And let's make sure double-sided is enabled here. We have reflect on the backside, and when enabled, the reflections will also be computed for the back-facing polygons. Let me just delete this sphere here and unhide our shader ball. Next, we have use irradiance map, which is enabled by default. And in this case, irradiance map will be used to calculate global illumination for the material. If disabled, brute force will be used instead, and this is actually a very useful option. If the object with this material has very small details and irradiance map isn't capable of giving a useful GI solution for the object, we can disable use irradiance map, and brute force will be used for this object instead, and the quality of the brute force solution will be controlled by the irradiance map subdivs number. Then we have fog system unit scaling, and when enabled, the fog color will be dependent on the current system units. You can go back to the second lesson of this section when we were discussing refraction and fog and see how this option can alter the way fog color affects the material. We have treat glossy rays as GI rays, and here you can define when glossy rays will be considered or treated as GI rays. When set to never, glossy rays will never be treated as GI rays. When set to only for GI rays, glossy rays will be treated as GI rays only when GI is being evaluated, and this can speed up the rendering, and it is the default option. And when set to always, glossy rays will always be treated as GI rays, and in that case the secondary GI engine will be used to calculate glossy rays, which sometimes might lead to artifacts. Energy preservation mode controls how the diffuse reflection and refraction color affect each other. Because V-Ray tries to keep the total amount of light reflected off the surface to be less than or equal to the light falling on the surface, so to keep this happening, the reflection level deems the diffuse and refraction level, and the refraction level deems the diffuse level. Let's see how this works in our render. Let me set the diffuse color to a medium gray color. Now, if we change our reflection color to a pure red, we don't have any red values left to be used with the diffuse color. So that's why you see this cyan color appearing in the diffuse portion of the material. If I use a pure green color as the reflection color, we only left with the blue and red components of the diffuse color. So that's why this purple color appearing in the diffuse section. But if we set the energy preservation mode to monochrome, the RGB component won't be affected by this rule, and only the intensity of the color will be affected, not their hue. So as you can see now, that purplish tone is gone. Let's just set the mode to RGB and set the reflection color to black. Next we have opacity mode, which determines how the opacity map defined in the maps rollout will work. First, let's define an opacity map. Maybe we can use BW43 as our opacity map. And set the tiling for the map to something like 3 and 3. We can set the filtering of the map to none. Now let me show you 3 different renders with 3 different opacity mode: normal, clip, and stochastic. The first render was done with normal mode, and in this mode the opacity map is filtered normally and no further interpretation of the map will be performed by V-Ray. The second render was done using clip mode. If I select my bitmap node and click the view image button, you can see our map has pure white, pure black, and in between gray values. When set to clip mode, the map values will be interpolated as fully black or fully white, and no filtering will be performed on the map. So in the render, as you can see, we have a very sharper opacity going on compared to normal mode, and the render time is also faster. So in the clip mode, there wouldn't be any shaded point with half transparency, either fully opaque or fully transparent, and it can introduce flickering in animations. And the final render was done with stochastic, which is quite like normal mode, and it generally reduces lighting calculations and can reduce render time if you are having tons of geometries using complex opacity maps, and it can introduce noise sometimes. Now let me set the opacity mode to stochastic, which is the default option, and delete the opacity map. And finally we have reflection and refraction interpolation rollout, and it's designed to speed up rendering of the glossy reflections and refractions, and they try to make the sampling of glossy rays more adaptive and therefore decrease the render time. But these cause artifacts in still renders and intense flickering in animations. And as you can see, the set of parameters here is very similar to Iridian's map parameters, and they are doing exactly the same. So I'm not going to waste my time and your time by explaining these parameters again. I'm just going to adjust the materials a bit and make it more reflective and render 2 versions with and without interpolation. Let me set the diffuse color to a very dark value, maybe 2 or 3. Set the reflect color to 220. And let's use BW38 as the reflection glassiness map. Now let me set the IR to 25. Make sure the BRDF type is set to GGX. Enable use interpolation for reflect interpolation, and let's set the mean rate to -2 and max rate to -1 maybe, and render the image. The first render, as you can see, was done with the interpolation on, and the second was a normal render without it. And as you can see, it actually took longer with interpolation in this case, and I can't see any difference between the two renders. I honestly never turn interpolation for reflection or refraction on, and I suggest you don't too. So that's about options and interpolation rollouts. In the next lesson, we possibly discuss bump and displacement mapping. See you there.